Now we will move to the official first session of the afternoon. For those who log in late, my name is Sunghyun Kim. I'll be presiding afternoon sessions today. The first afternoon session is about artificial intelligence and social good. And we have two presentations and two discussions. One of the discussants, Professor Junhee Choi, couldn't participate today due to personal reasons. So time-wise, we have two 30-minute presentations and two 7-minute discussions today. The first presenter will be Professor Michael Bernstein from Stanford University Computer Science Department. And he's going to talk about AI and society, institutional design, and engineering responses. Please welcome Professor Bernstein.
Thank you. Thank you for inviting me. And I'm excited to learn from you all about what you're thinking about these issues as well. I am a computer scientist. I'm also a designer. And so I think broadly about what it is that we're talking about when we're talking about responses to AI. And today I want to focus our conversation on ways in which we can or should make our values explicit. I'm going to talk a little bit about engineering responses we need to have, and also institutional responses that we need to have as AI diffuses more broadly into society. So if we're going to talk about the impact that AI has in society, I think it's useful to actually look back to history. Ancient history, tens of hundreds of days ago, not that long ago really, it used to be really hard to create public content on the World Wide Web. It was very complicated to actually get something out there on the web. You had to own a server. You had to set up an Apache server software on it, which I can tell you is, even for a PhD in computer science, not that easy. Speak this forsaken tongue of hypertext markup language. You had to learn a lot of things. But over time, what we saw was that tools arose to make it easier to publish. We saw things ranging from WordPress to Wikipedia to social media, all over the place. And the result of this was that it reduced what's known as the threshold, or sort of how much work you have to put in order to make use of a technology. So you have on one axis here the threshold, how hard it is to use the thing. And on the other axis, you have the ceiling. How complex is the thing that you can make with that tool? And so it used to be that building a full stack web application was really complicated. But HTML substantially reduced the threshold. It made it much easier to make web applications. It also reduced the ceiling. It sort of put a cap on the complexity of what you could create, but it was worth the trade-off because we could create much more. Things like Markdown, Medium, Twitter, each of them are just reducing the threshold further and further. So we see this over and over again. Graphic editing goes from an expert thing to something anyone can do on their phone. Video editing goes from expert editing to something you can do on your phone. And what happens when you lower the threshold, publishing goes from hard to easy, massive increases in adoption of the medium. And this is going to start to be the connection that I want to discuss with AI. Wide proliferation of use cases far beyond what the initial creators of the technology may be intended. So you have, yes, things like now social networks for knitting, massively collaborative encyclopedias, Twitter, but you also have co-option by motivated actors, groups that are trying to push disinformation or hate or cyberbullying or harassment, right? All of these things become easier, not just the good stuff. So with AI, yes, this was happening, but AI remains stubbornly high threshold. It was, you needed an advanced degree, an internship with Andrew Ng, a lot of effort to collect and train this kind of data. And what we think of when we think of AI advancing is that we think the ceiling's going up. We can do more and more with AI, more complicated things. In reality, when we start to look at the recent kinds of models that have come out, what are known variously as large language models and so on, what's actually happening in my mind is as important, if not more, is a lowering of the threshold. It is now as easy as just sort of telling the AI what you want to get it to reply to you to complete a prompt and respond. So these natural language prompts are enabling people, anyone without a technical degree, to be able to create what are called few-shot learners. These are AIs where essentially you give it a few examples and it tries to generalize from there across a huge variety of tasks. And that means that a much, much wider set of stakeholders, people all around the world, can now craft AIs where they couldn't have before. So just like with publishing on the web, where we saw that lowering the threshold enabled positive and negative co-option, as we lower the threshold to creation of AIs, we're going to see a profusion of all sorts of new interactive capabilities, multimodal interaction, all sorts of really interesting and positive things. But at the same time, we're going to start to see a bunch of negative uses of AI as well, ones that we need to be prepared to manage. So what are we going to do about this? At this point, the observation that AI, or artificial intelligence, presents societal and ethical risks, it's a horse that's already left the barn. At this point, that horse has crossed state lines, it's raced halfway across the continent, it's attracted international headlines, it's landed a shoe company scholarship. It is a big deal. AI has been implicated in all sorts of negative impacts, ranging from propagating disinformation, depressing wages for workers, perpetuating systemic inequality in policing and the justice system, advancing unequal healthcare outcomes. We can go on. Many people of color, women, and folks who are far smarter than I have really effectively made this case. So AI is not the first discipline to have to wrestle with these issues, but its concerns are felt more broadly, and the situation with AI today is extremely salient. And I think when the first reaction that we as technologists had was to try to make these models more fair, working to reduce disparate outcomes such that the AI is not statistically biased, say, against one group or another group. Now, that is a valuable work, undoubtedly. But what I want to push beyond this and explore what happens after that. Because even fair algorithms, quote unquote fair, provably fair algorithms, can get embedded in society in all sorts of harmful and unfair ways, right? Technologies can be instruments of politics. And so even if it's numerically fair, I can always stack the deck. I can always make it less fair. So this talk is about ways in which we have the opportunity to, and maybe the responsibility to, make our values more explicit. And I want to give a couple sets of examples around how we might reconsider the sort of technical approaches, the underpinnings technically of how AI works to make that more possible. And second, institutionally, as the president so kindly mentioned, an effort that we've been engaging in at Stanford in how we as researchers who are creating these technologies should be going through reflective practices along the way. So if we want to make our values more explicit, what I mean, just to get into this, is starting to ask questions like, whose voices are we listening to? Because early on, we were using AI to do things like, I don't know, detect pictures of cats and dogs. But today, when we look at how AI is being used, it's deployed in contexts like this. My research is focused in social computing, social media, crowdsourcing, these kinds of spaces where there are lots of people interacting through computational systems. And AIs are being used all over the place here to do things like find uncivil comments, detect misinformation, help moderate challenging conversations. And if you were to take toxicity classification as an example, this is an API, this is an AI that's used across all sorts of websites that have conversations on it. So think New York Times, many similar kinds of websites use an AI to detect when people are basically being mean online, being toxic. And if you look at these scores, at least within the American educational system, a 95 is pretty good. And what I want to point out in my argument, what I want to argue here is that this 0.95, while it's an accurate performance measurement, it's actually inflated. And that if we sort of flip around our perspective a little bit about what we're trying to measure, that in reality, the score is, it's not an A in my world, it'd be more like a C. And the reason why I want to point this out, and I'll show how we come to this conclusion, is that I think a lot of decisions we make about what we choose to launch, when, why, whether, and why, we look at these metrics and we decide, is this good enough? Something that's accurate with a ROC AUC of 0.95 is pretty darn good. But 0.73, I suspect many companies and institutions and civil society organizations would hesitate to launch such a thing. So here's what I mean when there's sort of something's rotten in the state of Denmark. With these kinds of tasks, we have to ask, how do they work? How are they trained? Typically, in artificial intelligence and machine learning, what we do is we go and gather a huge data set, and we ask multiple people to label a bunch of examples. And then what we do is we aggregate their results. There are lots of reasons we might want to do this. People might be concerned that someone's not made an accidental mistake. So we ask, say, 5 people. Here, 3 of them answered gray, 2 of them answered red. And then we just aggregate it via majority vote to create a ground truth label. So in this case, more people said gray than red. So this example is just painted gray. It says the correct answer is gray. And the AI learns that when it sees an example like this one, it should say gray. Now, for many tasks, this is the right thing to do. AI grew up on this kind of task. Is this a cat or a dog? Turns out most people will not actually disagree about this. If we were to take a vote, I hope most of you would say dog. Otherwise, it's far later in Pacific time than I thought it was, and I need more sleep. On the other hand, in many tasks today, it's not so clear. Here is a task that we see in social media, toxicity detection. Here's a comment, people saying that it's really gross to eat at a particular restaurant. It's shameful how this country has descended into blah, blah, blah. Some pretty aggressive comments. But if you were to actually take a vote, what you find is that whether the question of does this comment cross the line into becoming toxic, it's a split jury. About half of people say yes and half of people say no. So what are we to do about this? This disagreement is irreconcilable. It may be associated with political points of view, lived experiences, and so on. So what that means is that we can't just ask more people. Who's actually getting sampled matters. So while we may ask these 5 people, minoritized groups who are by definition smaller subsets of the population are going to be easily and always overridden by this majoritarian approach, this majority vote. So we take these 5 votes, and let's say that these 2 individuals who are colored a deep red here are known to be members of a minoritized group who are subjected to harassment. It doesn't matter, right? The majority vote entirely erases their perspectives. This is baked into how AI works. And this disagreement's everywhere. Comments that are in these data sets that are labeled as toxic are disagreed with on average about a third of people, right? So no matter what you say, about a third of people are going to disagree. Even people on large online forums disagree with each other about whether they should be removing things all the time. Fact checkers who are professional disagree with themselves if you ask them again later a third of the time. So what we've been developing at Stanford is something that we call the Disagreement Deconvolution. This is a project led by Mitchell Gordon, who's a PhD student at Stanford, along with collaborators from Apple Research and Stanford's Computer Science and Communication Department. Basically, what this does is it's a way to transform these performance metrics that so much of Silicon Valley bases its decisions on to adjust for this disagreement so that we can make better decisions. And the basic idea is to provide teams with a better sense of how this is going to be seen from sort of a human-centered perspective, from when it's actually deployed to end users. What percentage of them are going to actually approve of this? So what we want to try to do is move toward a metric that, instead of just trying to predict gray or say, did it get it right if it guessed gray, is actually going to give equal weight to each person's opinion. So here, if it guesses gray, it gets 3/5 or 0.6 performance, and if it guesses red, then the inverse. But this is actually really tough in practice. I won't get into the details, but people might misunderstand, might not have been paying attention for a moment, may have clicked accidentally. There's generally consensus that we just can't listen to everything at once either. So under the covers, there's a lot we can do to remove these sources of noise. So we sort of pull it down to the irresolvable disagreement, just to give the basic intuition of how you might be able to think about this. A lot of crowdsourced data sets already have the kind of information we need, because what they start to do when they're gathering the data is they'll ask a bunch of what are called attention checks, which are questions where they already know the answer. And then they run out of attention checks, and over time they start repeating them. So we can tell how often someone answers a different way on the exact same question. And we can use this to estimate how likely someone is to sort of vary from their most popular answer. Sort of lets us back out or deconvolve the whole data set to create this, this test data set that now we have a pretty good sense actually just reflects the distribution of the population's opinion on this issue. And it turns out when we take this, it has massive impacts on what you think of as the performance. So you go from something that looks nearly solved to something that is much less convincing, down at 0.73. And in fact, even if you had what's called an oracle, a perfect AI that always gave the most popular response, you could never do better than 0.73. You'll never be able to create an AI that's going to be able to, under these circumstances, perform better than 0.73 because people fundamentally disagree on this. And again, I think that we would change some of our decisions about what to launch if we take account of this. And we see the similar pattern across all sorts of tasks in social computing and social media, ranging from misinformation to classification of adult content, whereas traditional machine learning stays pretty robust. So we're not changing the metrics for these kinds of things that are maybe more like your eyes and ears can easily piece apart. We're really talking about these issues where people disagree. So what I want to get across here is that human-centered evaluation, thinking from where people are and where they're coming from, encourages human-centered outcomes. That if we can adjust our frame of reference as we're creating and evaluating the system, it creates different kinds of ethical and societal outcomes. So when we come back to this question of whose voice should the AI listen to anyway, we can think about going even further. This is a project we've been working on called jury learning, where we are attempting to really reshape more fundamentally how machine learning works to do better. And instead of silencing these voices, let's ask the developer, let's ask the person who's creating the AI to make those values explicit by saying whose voices should be included and in what proportion. All that is to say, right now, just like I was showing, you give an input and you ask a bunch of people, you take majority vote, and there's a label. What if instead we asked you to create a jury of say 12 members, could be any number, but let's say 12, and say what proportion of that jury should represent each group, each intersectional identity. It is to say whose voices you want to be listening to in what proportion. And you have those individuals in your training data set, and you have a number of labels from them. So as an example, in this space of online harassment, you might want to define a jury that's going to give more voice to groups who are commonly targets of harassment. These are women, Black individuals in the United States, Black women especially in the United States. So instead of just taking a majority vote on whoever happens to be in your data set, we're purposefully now using AI to model each juror's response individually, and then pull together that jury's vote. So you've now said whose voices you're going to listen to and how much you're going to be listening to each of them. So you might, for example, say for this jury that's half men, half women, it's split evenly across a number of different demographic and identity-based groups. More than half agree that this comment is toxic. This might not have been the case if it were just an all-white jury, but when you start to diversify, then you start to see something different. This actually requires us to change a little bit how we train these AIs. Typically, you're just trying to maximize performance on that sort of aggregated pseudo-human. Here now we're actually tweaking the machine learning pipeline to predict individuals and people. What would this person say? What would that person say? So we're going to do this by combining ideas from modern deep learning. This is the area that's seen such explosive growth in potential over the last 10 years, and something known as recommender systems. Imagine that if these online video services, for me, this would be something like Netflix, could predict your opinion, not just of a movie that's come out before, but of something that just came out. That's the basic idea here, that we're learning a little bit about relationships between people. And if this person thinks that, what would this other person think? So there's a required diagram here. Essentially, what I want to convey here is this is not changing really much about how you build AIs in terms of the parts that are making it performant. All we're doing here is adding a requirement that you have to, that you're going to be able to learn across people and predict each individual's response rather than the aggregated pseudo-human's response. So just, I want to give you a sense of the power that this can have. So we recruited a number of moderators from online communities, online social media, to create these juries for this kind of task. And we looked at whether their juries had represented more diverse opinions, and whether, by the way, in the training data set, it's mostly white. It's mostly people who look like me, frankly. And we also asked whether this changed how the AI behaved. If you created this jury, does it change the classification outcomes? And here's what we see. The red bars in this graph are the representation of each group that you can see in the state-of-the-art training data set. What you can see on the far right is that red bar way up there. That's, again, people who look like me, white individuals, hugely represented, over 70% of the data set, and everyone else kind of hanging out near zero. And what happened was when we gave people the opportunity to say whose voices they should be listening to, they drastically increased the representation of these other groups, doubling, tripling, or quintupling it, sometimes more, and reducing the population of individuals, again, who would look like me to compensate. So you get a much broader representation of voices. And that broader representation of voices changed the behavior of the AI. Instead of what it was doing, about 14% of the classification outcomes actually shifted compared to that previous state-of-the-art classifier. And the most likely ones to flip were these ones right on what's called the decision boundary, where it's really unclear, the most divisive stuff. This is really important because if the stuff that flips is the most divisive, those are the things that really determine policy. There's a lot of instances where, like, yeah, we can all agree one way or another, but it's those ones where that are really near the decision boundary, right at the edge, right at the tip. That's where the de facto policy is made. And so I think we have evidence that this kind of approach, simply asking people to explain who they want to listen to and in what proportion, will make meaningful changes to the decisions that these AIs are actually tasked with making. So far, I've talked about these technical solutions. I've talked a little bit about why AI works the way it does, why that's problematic, how we might shift it around to sort of change the voices. But this is itself, I think, a little bit too much reliant on techno-solutionism. It's like, oh, we got ourselves into this problem, we can just program our way out. And that's not true. We as humans living in societies need also institutional practices. So again, coming back to these examples, AIs, even perfectly fair, transparent, explainable AIs, get embedded inside of racist or problematic systems regularly. And that's not just in the US, that's worldwide. And so what do we do about this? This is challenging because everyone, if we're going to succeed at this, we need more people participating early on. And here I'm focused on researchers. These are the individuals at institutions like mine who are really driving a lot of the innovation in this space. So what should we be doing? How do we get more reflection going on about these issues? Now, there's a bunch of work that's been done that's really great, thinking about what you would think of as opt-in approaches. I can go to office hours. I can go to Professor Joo-Ho Kim, and I can say, what should I do? And he can tell me his advice. Or checklists, other kinds of sort of opt-in things where I say, I need help, and I can get help. This, of course, only is best positioned to help those who self-select, and those who are not interested, unfortunately, are less helped. Now, there's also been a lot of useful work recently in adding broader impact statements to the research papers themselves, so that when I, as a researcher, finish my research and I send it off for peer review at the top venue in my field, now they will actually review the kinds of broader impacts that I have. So if my technology is being used for surveillance in inappropriate ways, if I'm trying to improve that, my paper may get rejected on those grounds. And that's also a really important improvement. But it's also written only typically right before the deadline for those submissions. So there's only limited possibility of impact there. So we want to rewind a little bit. Now, in the United States, I need to give a little context. Usually when I say we need reflection, people will respond with, well, you have what's called an IRB, or an institutional review board. These go by different names around the world. They're like ethics review in certain countries and other kinds of things. In the United States, the IRBs grew out of major ethical violations that happened in medical research early on, which means that the regulations around them grew up around risks to what are called human subjects. This is to say the people who are directly involved in the research. This is what they care about. And unfortunately, they don't care so much about the risks to human society. And in fact, if you look at the laws in the United States that govern what these IRBs, these institutional review boards, are supposed to look at, they say you may not consider long-range effects as within your purview. So artificial intelligence research is seen as basically outside of IRB purview. That means that I could go in, scrape a bunch of pictures of people against their consent, train an algorithm about it, and release that model out on the web, all without needing any ethical review. And I would be totally okay by the letter of the law. This is the gap that we're seeking to address. Now, I should say that some IRBs are doing a great job at taking a broader lens on this. Microsoft Research, which is a top industry lab in my field, has something called an ethics review program, a registered IRB led by Mary Gray, Duncan Watts, or created by Mary Gray, Duncan Watts, and Eric Horvitz, that takes a broader view on this. But I will say my institution doesn't do this, and I don't know very many who do. So in concert with efforts like theirs, we're trying to widen the lens. So what we created at Stanford is something called the ESR, or Ethics and Society Review. This is work that recently, actually just a couple weeks ago, appeared in the Proceedings of the National Academy of Sciences. So if you want to read more about it, you can find it there. The ESR is a process that we've worked together with the Stanford Institute for Human-Centered AI. We've created to facilitate researchers in AI in mitigating these negative ethical and societal aspects. And the basic idea, the basic insight behind it is that, well, there's no law that says you have to do this, but you still need money. So we're going to hook into, as a gate to access funding, that you cannot get your grant funding from this program until you've completed a review process on the possible downstream impacts of your research once it leaves the lab. The basic idea is that researchers at Stanford here will submit what they want to do, some grant application, and a brief statement, about a page long, because these are short grants, on what are the possible ethical risks. They have to say, here are the risks, here are the principles we're going to follow to mitigate those risks, and here's how those principles are instantiated in our research design. Then grant review happens as normal. So Stanford's HAI, its Human-Centered Artificial Intelligence program, reviews the grants, decides who they want to fund. They then hand it off to us, the ESR. And we bring together a panel of faculty from around the entire university. You can see some of the departments that were represented in our first panel here, ranging from anthropology, communication, engineering, history, medicine, philosophy, all over the place. This panel iterates with the researchers and says, have you thought about this? What about this kind of concern? How might you address this? Until everyone is satisfied, at which point we make a recommendation to the funding program and funding is released. So PIs, who are the researchers here, are given lists of possible issues. Like, for example, if you're creating a tool for helping learners, are low-income students represented in your data set? Or is your algorithm going to learn only how to help people who are already affluent? So here's a risk that might occur, a principle that they should follow in mitigating that risk, and how that mitigation is specifically instantiated in their project. So for example, here's a real project that's been going on at Stanford that ESR worked with. So they're doing something around stress sensing. So you're at work and you want to have something that helps you understand how stressed out you are. The researchers named concerns around surveillance, but they kind of stopped there. The ESR says, well, what are you going to do about this? There were meetings, there was feedback, and eventually the team decided to create a privacy-preserving architecture that would essentially make sure that everything happened on the worker's local phone so that the employer doesn't automatically get access to it. So this process has been going for about 2 years now. About 75 grants have been reviewed. I just want to very briefly give you an overview of some of the things that we've learned. One, we surveyed a number of the researchers. A lot of them got back to us. We engaged in interviews. We got feedback from the panelists who gave that feedback. Every single person who engaged in this was willing to continue with the process. I expected to get more pushback, saying, red tape. No one seemed to want to get rid of it. And in fact, 2/3 of those who worked with us felt that the process, just even writing and iterating, had influenced the design of their research in some way. So what happened was that people felt like it was this forcing function, this commitment mechanism, saying that it made me talk with the other researchers. I wasn't aware of some of these implications, and it helped me talk with them about the requirement. That it raised new issues. One of them said, we might flip our whole research approach yet. We don't know the answers, but it's actually changing how we're thinking about the project. Now, what people want more of is more scaffolding. We said, hey, please think about the ethics of your work. And they said, well, where are we supposed to start? So just having a blank page was definitely a space that we could help them scaffold their thinking better. Saying, you should tell us how big of an issue this really is. Didn't help us make those decisions and whether the positives outweigh the negative. So we saw all sorts of themes ranging from who's harmed, how we increase the diversity of the people represented, what if other malicious actors get use of it, who is and isn't in the data, and so on. Ultimately, what I want to leave you with is just this notion that we embed values into our designs of our technology, always. And I think the history of AI and of computer science and of interaction has been hiding those values. Something that the STS community and others have pointed out is problematic. And what I want to do is help make those values clear, make them visible, and allow us to interrogate them and discuss them. So I'll end here. I want to thank you all for the invitation to speak with you and to hear your feedback. I want to thank especially the students who helped me do the work, collaborators who helped me do the work, those who supported the work financially, and to the discussants who I really look forward to hearing from. So thanks again.
Thank you very much for a very important presentation, Michael. Let's move directly to the second presentation by Professor Simon Wu from 성균관 University. He's going to talk about adversarial effects of AI. Professor Wu, please go ahead.
Okay, hello everyone. Thanks for joining my talk, and it's a great pleasure to be here today here. And my talk is about adversary effect of AI. So can you hear me okay? Everyone's okay? Can you hear me okay? Great. Okay, so as you may know, AI has been used in everywhere, many applications starting from computer vision, so robotics and art and technology and medical science and many different areas. And this is one example in using computer vision application. There are many faces, many tiny faces, and computer vision technology using AI has been developed so much, and so this is one example of using computer vision application using machine learning and deep learning. So as you can see, there are many faces, and this deep learning machine learning algorithm can detect very accurately all the faces here. And also, you may have this one in your home, AI speakers becoming popular. And there are a lot of good AI and deep learning-based technology out there, such as speech recognition and question and answering system and cloud technology. So this makes really our life easier and convenient. And also, as you can see, StarCraft, one of the game that popularly played in Korea, and the DeepMind proposed Alpha Star. They can even play better than humans expert, and this is I guess another next version of the AlphaGo. And so AI has been used in many different domains, and large companies such as Google, Amazon, and even Naver and IBM, they providing these various types of this AI service to the end user, so that people can use these types of AI based services without knowing details about machine learning algorithms. So it is getting much easier and better and more convenient, and they can be used in many different applications. And one example would be the face and object recognition application, where Apple phone already employ this Face ID, and autonomous driving and immigrations and building entrance and banking, etc. So there are a lot of face recognition algorithms can be used. So not just in terrestrial application, but in space domain, NASA or Korean Aerospace Research Institute, KARI, in Korea is also very interested in this AI technology to apply, collecting large amount of data in satellite, where satellite has a very limited bandwidth and storage capacity and limited communication contact with the ground station. So even these there are many space applications using AI and big data. So these are one example. Also, ground systems and data analytics and decision support and data-driven discovery, a lot of science applications. Also, they are looking into this machine learning and big data technology. So AI will be good and perfect if the world and technology are perfect, right? So, but unfortunately, technology are not perfect, and the people who are using this AI technology can be malicious as well. So there will be potentially some of the adversarial effect. So there are many researchers and professors are interested in improving these machine learning techniques and accuracy. However, there are very few people actually looking at some of the adversary effect of the AI. So one example would be adversary effect can be caused by this incorrect result, maybe misclassification and inaccurate prediction, and some of the unforeseen mistakes that AI can make. These are basically caused by machine learnings are trained with the training set, but some of the test set include unseen data. Then naturally, machine learning algorithm or AI algorithm is supposed to make a mistake. So these are somewhat expected. However, these can cause some of the bigger issue to individual and society. So I will show you some of the examples here. So adversary example and deepfake, and there are some bias and fairness issue that Michael Bonstein already mentioned a little bit. So I will talk about some of this using using some examples. So adversary example is one of the popular case where people see this panda as a panda, right? So human can perfectly recognize this as a panda. However, there are some of the small imperceptible noise being added, and very highly accurate this image classification algorithm makes mistakes. So it predicts as a gibbon. Gibbon is one of the I guess the chimpanzees breed, and it predicts as a 99% gibbon, and maybe, but for human it is perfectly panda, right, with a small noise being added. So this adversary exam clearly show where human. It's obvious to human would never make a mistake. However, this highly accurate machine learning algorithm makes these types of trivial corner case mistake that a lot of researchers are trying to understand these examples and phenomena these days. Another interesting case would be in the top part, there are bananas, right? So people see and classify as a banana, and highly accurate image classification algorithm think almost 100% this as a banana. However, this weird types of sticker patch is being put together with the banana, then somehow this highly accurate machine learning algorithm think this is a toaster machine. So the deep learning has been very accurate and then advanced a lot. However, there are little lacks of explainability, and sometimes it is a black box algorithm. So we don't know why machine learning algorithm makes these types of mistakes as well. So this is one example where machine learning algorithms sometimes make trivial mistakes, which is interesting. Also, the middle part is actually services that are provided by a large company, and then they provide some face recognition algorithm. So if I put my image with some of the noise, and then it can make incorrect predictions. So this is also possible to even exploit and explore the mistake of the highly accurate machine learning algorithm, commercial machine learning algorithm offered by large companies as well. So these types of trivial mistakes are easily caused by changing the boundary a little bit here. So one of the core idea of the machine learning is how to draw the line between two classes. And if we can shift the data set a little bit, or if we can change the boundary with the noise slightly, then as the Michael 번스타인 already said a little bit, some of the opinion can be toxic or shifted. So this can be actually important problems. This is toy example. However, this can be important issue when it applied to important critical application. So these are some of the image we tested, and I call it as an attack, but it can consider as a mistake. So Naver and Amazon, they make almost 93 and 83% mistake for classifying some of the famous people here. So, previous example can be toy example, right? So, face recognition, some people can be mistakenly classified. However, in autonomous driving application, where a lot of large companies are trying to build autonomous car, and if we put some sticker sign on the stop sign, it makes a incorrect decision. So in the stop sign, it recognizes the stop sign without anything, but if we put a little patch here, it classified as a yield or speed limit. So some of the critical application, if the machine learning or AI system make mistake, then it can cause some of the serious problems and mistakes. So there can be a bad users, right? So if the world would be perfect, if the human users are fair, and then not exploiting, but there are attackers who can exploit these types of mistake. So original message image can be classified as a cat. However, somehow attacker or bad user can exploit these types of mistake to classify as dogs somehow. So these are another examples. And fairness and bias issue is also big, and it's been less explored. So these are algorithmic bias that exploited by the research at MIT. And what they said was, the conclusion was the classifier or AI service that built by Microsoft and open source and IBM, and these highly supposed to be accurate algorithms are making mistake toward people who is a little darker, more darker, and female. So these fundamental problems are actually algorithmic bias are caused by a lot of data set. Data set is not composed in a fair way. So data set and algorithmic bias is also AI system has. Also, these are one actually example that popular K-pop stars been analyzed using Amazon AWS machine learning services. And recently in US, they released a news article. Lawmaker cannot be correctly recognized by these commercial face recognition API, where a lot of governments in US, they are actually using these types of, trying to use these types of services. So if they use these types of services, a lot of even politicians are mistakenly classified. Even they are classified as criminal people. They forcibly match it. So AI system is not perfect, and these are some of the examples. And another interesting area of the AI system can be misused is deepfake, which I have been researched for about past 3 years. And as you can see, these are perfectly fine human faces, and but these are not real human. They are completely generated by the AI system. So these are very fine, real looking, but they are generated entirely by NVIDIA team, and the technology used for this generation called the GAN, Generative Adversarial Network. So GAN technology are getting better and better, and it can be used in a good way using metaverse technology and creating AI-based a lot of services and human AI players, etc. So getting these types of AI services are getting better, and these generate images have much less artifacts, and they are getting perfect. So what would this be a problem? So it can be used for creating a fake news. So they are not real human, and also there are political news, and politicians can be created by these types of deepfake technology and apps. And also, one of the largest problem is these deepfake technology can be created for adult material. So unfortunately, in South Korea, K-pop stars are nearly composed of 1/4, 25% of this adult material in the world. And these are original and deepfake of the Obama, which is one of famous example, and then they can be also misused. So traditionally, deepfake usually targeted celebrity or politician, but now they are getting down to the normal people, even including news. And in Korea, there are incident called the N-Bombang, N-channel room, Telegram room, and they are use this type of deepfake to hurt other people as well. So deepfake technology and AI technology are good, but if they are used unethically or unfairly, then it can hurt individuals and society. So let me introduce briefly about deepfake generation method without going into too much details on technology. So the core idea is very simple. So there are two faces, A and B, I want to change, and these encoder can extract important critical feature about the human face A, and then it can reconstruct, and we can do the same thing for the B. And then if you want to create a deepfake or swap the face, we can just change the latent face, most important part of the human face, and we swap those, and then we smooth that. So that's what the decoder does. So there are little more different techniques to make it deepfake a little more perfect and finer, and these are some of the technology and process. And there are also data sets are released because in AI and machine learning, data set is one of the important things. So there are, for the research, these types of data sets are available. And even with the same types of two input, different types of deepfake can be generated, and now it's getting even better, and it's even hard to notice. Yeah. So these are some samples that I created with one of my students, and then these are Robert Downey Jr., and then these are some of the examples we created. Also, not only creating a face swap, but swapping faces, deepfake can make something that I didn't talk about. So someone can attach my faces to someone else, so exactly they can make me speaking in that way. So these are one of the samples that I can present there using these technologies called the few-shot learning and neural talking head models, where people can follow a speech of someone else's. So so what we can do, right? So deepfake can be created using AI technology, but how we can prevent this? So in order to cope with this, and then in order to detect this deepfake, we can also apply deep learning algorithm. So I've been working on this deepfake detection and generation for last 3 years, and the idea is fairly simple. We need to have a large amount of real data and then large amount of fake data. Then we can build a classifier, such as we are classifying dog and cat. We like to detect the real and fake. Then we can train the machine learning algorithm and then develop this and test it. But there are issues. There are always a new types of misuse will be coming. New deepfake will be coming, and then it will take a lot of time to detect, collect data set. And also there are also privacy issue with using real people's faces as well. And so it is impossible or not practical. Every time new deepfake or new misuse coming, then we have to train and collect the data again and repeat this process. So it would be inefficient. So my research has been focusing on, is there a way we can reuse these types of architecture we developed before, and also using small amount data to detect new types of deepfake, or even using the very small amount of new deepfake data and then leverage the existing previous trained machine learning model to detect the new types of deepfake. So these are called the few-shot learning and transfer learning, and also domain adaptation. These types of core machine learning algorithm can be used to detect these types of deepfake for the futures. Also, there has been a government and industry effort to cope with these types of deepfake. So Facebook, Google's, and Kaggle, they got together to create a challenge for defect detection challenges, and it has been very successful. And also US DARPA, they are very interested in these types of detection technology, and they have been investing these types of effort and privacy issue in machine learning and bias and fake news detection in the past years. So government is making a huge effort. Also in Korea, there have been a large grant from the government to detect these types of misuse, and also Kakao and other large private company in Korea are also interested in preventing these types of misuse. So probably this would be the last example you may already know. Tay was actually AI chatbot developed by Microsoft, and Microsoft has a very good intention, right? But it turns out a lot of toxic comment and bad comment cause this Tay to learn bad things. And also there has been a similar effort and attempt has been made in Korea. There's called the Iruda. Iruda was a Korean version of Tay that Naver, Kakao, they actually lead these types of chatbot. But so these types of AI technology are still showing some of the immaturity, or we need some of the more robust response. And we are still looking at these types of issues, how we can actually make the AI system more safer and more trustworthy and much fairer and then robust. So these types of research would need to be done in next coming years. So my final concluding remarks would be there are balance need to be made because I think we have spent a lot of time and effort for improving the performance of AI, and majority of AI research are very interested in that area. However, as I show you little bit, there are security and privacy and even unfair use and result coming out AI can cause many problems, not just individual, but Bonstein said on society as well. And malicious use, we need to detect those, and there are good AI and bad AI. I think we need to balance those and try to improve those bad side or mistake that AI has from the technical perspective. That's what I'm trying to research for next few years. Yeah. So thank you everyone, and thanks for listening. Yeah, this is actually concluding my talk.
Thank you for very interesting presentation, Simon. Now we have done 2 presentations and we have 2 discussants ready for discussion. The first discussant is Professor Joo-ho Kim from KAIST, Department of Computer Science. Please go ahead.
Great. Can everyone hear me okay? Awesome. Yeah, thank you for having me at this wonderful event. And thank you, Simon and Michael, for the fantastic talks. I'm a computer scientist professor at KAIST, and I do research in the field called human-computer interaction, where I care about building technology that can make AI more useful for humans. I'll first I want to make this somewhat casual and informal in that I want to first refresh where we are now, especially focusing on my personal data points, especially in the Korean context. And then I want to share some observations that I've made from the 2 talks and also from my personal research and teaching experience. And then I'd like to end with some concrete catchphrase style messages for students, parents, and people at companies and the general public. Okay, so let's start. Where are we now? Obviously, everyone is talking about AI. They're excited about AI and doing something about it. Let's start with schools. Kindergarten kids. They're learning to code and build apps through block-based programming tools like Scratch, for instance. And there are even private tutoring institutions, 학원 in Korean, that teach these small kids how to code and computer science and even AI. And as a professor, I go into KAIST admission interviews for undergraduate students. And there are many, many high school students who have experience building deep learning models. I'm surprised by the level of technology that they have been experimenting with. And at KAIST, undergrad students can choose their major after their first year. And what's happening these days is that more than half of an undergrad class have been choosing one of the 2 departments. Can you guess? Pure science and EE, electrical engineering. These are the 2 most AI-related departments at KAIST. On the government side, there are these big nation-level blueprints, multi-year plans, and reports coming out almost every day. Billions of dollars of R&D investment announced every week, increasing every year. Companies too, they want to hire AI experts so badly at 2x, 3x salary, and we hear these legendary stories about how this outstanding engineer was hired at this company for this amount of salary. And what's happening in the real world, more AI is getting into products and services that we use every day. But ethical and privacy issues, like those examples that we heard from both Simon and Michael, is getting more attention from people. And AI being accused of being a black box, lacking an explanation, is also becoming problematic. As a result, I would say that the general public's awareness of both the opportunities and the risks of AI is slowly going up. So based on sort of this understanding of where we are, I want to share a few observations that I've made in this kind of space. First is about democratization of AI. We talk a lot about how to make AI more accessible to more people. And both Michael and Simon told us about how the new apps and services are lowering the threshold for AI, making more accessible. But just having these tools is not going to be enough, right? Because we need to be asking these questions. Do people know why these things even matter? Do people have concrete ideas for how to apply AI to their domains? I do worry that we focus maybe too much on making AI easy, because getting AI to work is not actually easy. Right? I don't mean just the technology, but there's so much more than technology to worry about, like ethical concerns, bias, transparency, privacy, minority voices being suppressed, all these great examples that we heard today. Getting AI to work is not easy. Trying to sound like it's easy, I think, is somewhat misleading. Second observation is that maybe we're too focused on model performance. Accuracy is only one of the many factors that matter for AI, but most of our attention is centered around it. Like, is this AI accurate? Is this AI performing really well? Simon's examples like deepfake clearly show that accuracy isn't really the big problem. Maybe higher accuracy of deepfake is the problem, right? So what does accuracy actually mean? And what level of accuracy is adequate and appropriate for a particular application? We always think the higher is better, but maybe not. Maybe there are other things to worry about. Even for accuracy, Michael's research shows that incorporating voices from the minority and diverse groups really challenges the conventional metrics of accuracy, as we know. Accuracy and the AI itself may only be a small piece in the entire ecosystem. And that leads to another observation, that AI adoption is limited not because of technological limitation, but because of socio-technical barriers. People might be resistant about applying AI to their context. There may be policies and legal systems that are not really ready. Maybe in the company, the CEO says, let's apply that AI to our product. Engineers work for 6 months, realize that it's not possible. It's not for us. There's a huge gap between this 1 minute, fancy YouTube video that shows this fancy AI working to getting it to work in your application. There is a huge gap, and we think it's a rather easy job to do. Indeed, it's not. So we need better systematic processes and for developing and monitoring AI. And in terms of societal impact of AI, how do we encourage students, companies, government agencies, and the general public to think about this societal impact of AI? I mean, people know that these issues are going to cost us a lot, and we need to be asking a set of questions, like those questions that Michael covered in his talk. Like, is the minority voice heard? Who are the diverse stakeholders? How are their needs and preferences and constraints reflected? The thing is, are we educating our students to be able to ask this question? At KAIST, we have dozens of AI courses. Like every new technology, you name it, we have a course. But there are very few courses that actually talk about the societal impact of AI and how AI could be successfully applied in practice in a human-centered manner. So how would we be able to teach AI in a better sense? As an educator and AI and human-centered technology researcher, I keep thinking about what it all means for education. How should our computer science, AI education be redesigned to help our students be more prepared and take initiative in the upheaval that's upcoming? I recently taught this class called Smart Life as sort of an experiment myself, where I co-taught the course with 2 other professors in design and psychology. So we tried to collaboratively design this course to students with very little AI background and walking through this human-centered AI design process. So we learned many lessons about it. I'm not saying that's a perfect example of anything, but I think we need more efforts like that, where we need to equip our students to have the skills for designing more value-sensitive AI and to also collaborate with AI. Okay, to wrap up, I'll just leave a few messages. Hopefully many of you fall into one of these categories. For students and parents, don't just teach AI, don't just learn AI, teach and learn human-centered AI. Okay? Second message is for AI developers and researchers. Thinking about the societal impact of AI, I don't think it's just some homework that we have to do or like a tax that we have to pay. And I think increasing the societal impact of AI does indeed require significant technical efforts. And it's not just a job for social scientists and ethicists to handle. So my plea for computer science students, developers, researchers is to engage with these tough technical challenges. And finally, for the general public, my message in preparation for the upcoming upheaval is to learn how to collaborate with AI. Learn how to live with it, learn ways to use it to your advantage. But we should also find ways to be inclusive in our use of AI by listening to other people, considering various stakeholders, and especially thinking about those who are suppressed. Okay, with that, that's my quick discussant note, and I'll hand it over to Charles. Thank you so much.
Thank you very much, Juho, for your very insightful discussion. Next discussant is Professor Charles Crabtree from Dartmouth Department of Government, who can give us a new perspective from a social scientist, I believe. Charles?
Yeah, thank you very much. I'd like to thank SKKU for hosting this event and for inviting me to discuss what I think are two really important presentations. I'm honored to be here among such great company, and I'm particularly grateful to Zhang-Wu, who may be in the room somewhere, for this opportunity. Now, Zhang-Wu suggested the discussant should talk about the forest, not the trees. He suggested this after I'd already created a discussant slide deck focusing on the trees, actually, so I'll send that over to the presenters later. I'll try to maintain this focus, but it's important to remember that the forest, in my view, differs from the forest of the presenters and the other discussant likely see, and this is because I am, as our moderator suggested, a social scientist by training, so I'm the odd one out on the virtual panel. I'll basically be playing the role of a semi-informed interlocutor, the voice of the public and not the techno-elite, many of whom are actually kind of like cloistered not far from my office here. So I'll also try to keep things brief, knowing that everyone's been listening to a lot at this point. So to begin, I should say the work is provocative and needed. It addresses, I think, huge questions. Who should we include in designing and evaluating AI? How should we protect people from AI? More meta work like this is desperately needed. I don't know about the extent to which this work is encouraged in computer science and related fields, but it certainly isn't in many of the social sciences that actually might have something to say about this. So I think there's something about higher ed incentives that need to be sorted out. I think this work leaves some big questions unanswered, at least for me. There are 5 particular issues that came to mind while reading through the materials. And I'll raise a bunch of questions. Some of them intended to be slightly provocative. And I don't have any catchphrases at the end or buzzwords to offer, unfortunately. So one thing that kept coming back to my mind is how can we construct minimal harm AI in a fundamentally unfair world? Most of my substantive research focuses on outgroup discrimination, in the US mainly, but also all around the world. And what I've learned from this, and what won't surprise anyone in the virtual room here, is that the world is rife with prejudices. These drive, influence, and deeply scar all data generating processes we have. So given this, how can we construct systems, the vast majority of systems, even all systems, that use these data but produce unbiased outputs? And I know there's some work that's been done on this that adopts kind of a wizard viewpoint, right? The idea is we can science our way out of the problem, that we can move past garbage in, garbage out to biased in, unbiased out. I'd love to hear the presenter's perspective on whether this is possible, and if it is possible at scale quickly enough, and I think this is crucial, for enough AI systems to halt or slow the damage done by systems currently in use. In a world of adversarial coders, and when coding is promoted, even in elementary school, how do you fix all the algorithms that are being created, right? 2, if it is possible to infuse AI with our values, which I love as a general idea, what values do we use? Michael, I read all the work that you sent around, and I think it's fantastic. I don't mean to get too much into the trees here. I think this idea of representation in AI is wonderful. And I can really see its positive outcomes. But there are lots of dimensions where we need representation. And representatives across different groups might mask variation of opinion within their own communities, right? Descriptive representation matters, we know, in political science, but so does substantive representation. And I'm wondering the extent to which existing systems might accommodate that. In addition, what values are fair to add to a system? The problem, in my view, is that there's little consensus on values. Indeed, most of the last decade's largest political debates in America and elsewhere have been created or inflamed by different perceptions of what is ethical and good. So I'm not sure that we have consensus on this and on the right values in any aspect of life. And that raises an issue of who determines the values here, right? How do we know that's the right set of values to include, the fair set? So moving to the third point, to answer these questions, I think that we need more than academic research or engagement with these issues. We need a wider set of voices and truly democratic AI governance. But how do we encourage this when support for any form of democracy is by some measures on the wane across the globe? And people seem all too willing to basically capitulate their opinions to some sort of authoritarian leader. How do we get people to care about AI when few know what that term really means by some of the work that I've read? And when mobilizing democratic action on other hugely pressing issues such as climate change remains an elusive goal. So I'm just curious what kind of visions of democratic governance you might have in mind. Keeping an eye on time, I'll quickly go through the last 2 points. At the risk of being potentially too provocative, I'm wondering about how serious the relative harms are for some uses of adversarial AI compared to other harms that exist in the world. The code can create bad outcomes, but how bad are these outcomes compared to those created by other types of code like law, right? So for example, deepfakes might well be bad. I think they're horrible. I'm horrified by them. Some anecdata definitely suggest they are. Some rigorous empirical work suggests that they don't seem to influence people much. So I'm wondering what the stakes are here. It seems clear to me that in autocracies, these are potentially hugely problematic because regimes have a monopoly on producing media and deepfakes. What about in more open media markets? Does misinformation basically counter misinformation? Deepfakes often expose viewers to messages that they already believe too, because of media self-selection issues. So if people's priors already set, how big of an issue is it just subjecting them to more information that reifies those priors? Another way of thinking about it is, what's the fundamental difference between reading that someone said something they didn't say, which people could already convince people of now, and seeing someone say something that they didn't say? What's the delta in terms of people's beliefs here? And wrapping things up again with an eye on time, there's also this issue of content regulation. I've done a lot of work on human rights, and I wonder how we think about censorship that goes against these values. It's encouraging for me, even though I'm not entirely sure about the total harms of deepfakes, that there are ways that we might get ahead of them and moderate them. But I wonder what kind of values are encoded in that type of censorship. And it's hard to correct perceptions if these deepfakes have already been out and if they do have an effect on people's beliefs. So it suggests we should potentially pre-screen content maybe, or immediately remove it after posting. There are systems that are like this. China uses a set of systems like this to engage in censorship. But I'm wondering how much content moderation should platforms actually practice, and what values determine what kind of content they should remove. So all of this in my mind, I love the conversation here today. And what I kept thinking is how necessary it is for social science fields like mine who do very, very little work in this area, probably dip our toes in a little bit and partner with people like all of you and try to answer some of these questions. So thanks again for having me here. And I think that's the rest of my time. Thank you.
Thank you, Charles, for your nice comments. Everybody kept their time limits very well. So we have more than 10 minutes left for general discussion in the session. So let's start by giving an opportunity to Michael and Simon for responses to the points made by the discussants. Let's start with Michael, please.
Sure, such great points. You know, going backwards a bit, are deepfakes, you know, is code worse than law? Well, I have an ability to impact one of those, less so an ability to impact the other. So that's where I'm starting. At the same time, you know, concepts such as the liar's dividend argue that when deepfakes pollute the information environment, then you can lower trust. This is, you know, what you know the common information attack on democracy, right? Like if no one can trust information, then democracy can sort of die in darkness. And so I think that there's there are real serious concerns there. You know, they're not just it's not just toys. You know, Juho, Professor Kim brought up these issues around not even having metrics. Like deepfakes, you're right, we don't really have very good metrics around those at all. Like it's like inception scores, which are based on like CNN's based on ImageNet. Like we don't even know what we're measuring here. Fidelity is not even like a question that we know how to ask there. So I think that understanding how these come into the context in which they're used, that's the space where I think both the social scientists and human-centered designers actually have a space to have some impact. I really took as another thought, I really took your questions around who determines the values, descriptive representation versus substantive representation to heart. I think that's absolutely right. My hope is that as we start to move toward these directions, it becomes more possible to create participatory and democratic hooks into these systems. If instead of saying, here's a bunch of training instances, let's debate different, gradient boosted, methods or something like this, like that doesn't make much sense. But if we say, there are 100 positions on this jury, and I'm not saying that juries have to be the way we do this, this becomes a thing that is much easier for our public to reason about, debate, and vote on. So, methods of social choice and others, I think, become more feasible. So I think that there's a lot of work that we as technologists can do about asking where are the right hooks for making this work scrutable, governable, and impactable, legislatable, right? So it may be, there are cases where we may want to actually intentionally reduce the performance of some of these systems so that that becomes possible, that like the interface with law or with people reasoning about the systems becomes better. And there's a lot of work working on that in various different ways, but I think we can push further.
Thank you, Simon.
Hello. Yeah, can you hear me? Okay. All right, Charles and Juho, excellent point, and you made a very, very good point. So yeah, a couple of things I like to discuss and respond. So I think it's possible to make the system a little more, machine learning system more robust and then fair and unbiased. And there are, I think, active research are going on and started. And so I think a lot of those fairness issues coming from data set. So one possibility is actually practically we make a better data set, more fair data set is one issue and one approach. And the other would be, actually we try to acknowledge some of the limitations or the nature of the machine learning. So don't blindly trust the result produced from machine learning algorithm, but we try to use that as a part of reference point, and don't blindly believe it, but verify it and acknowledge its limitation, and then try to improve the interpretation side. So we can use the AI system in that way. Then I think it can get along with the human side and human ability, and use AI as a tool to help and solve our problem instead of entirely trusting and believing AI. Yeah, that can be one directions. And another part would be there are privacy issues. So privacy would be going to be bigger and much more important in the near future. So from the machine learning side and AI designer perspective, I think we should follow some of the GDPR or privacy law that they are enforced for the other systems. And there are currently some of the effort going on to follow those privacy laws. So machine learning AI systems should follow those privacy laws as well. And also there are ways we can make data a little more private. So we can use different technique to anonymize data, human faces or personal data using blurring or anonymization, etc. So those can be applied. So they can preserve the privacy while achieving the good performance. So those are active research area. Yeah, from the technical perspective, I can provide. Yeah, 2 cents. Yeah.
Okay, thank you very much. So thank you for your participation.